Hello all. In this lecture, we'll see about structured query language. And mainly, we'll see about create, drop, and alter commands in structured query language. So actually, these commands are DDL commands, data definition language commands. So if you want to create the schema of the database, and if you want to change the structure, or if you want to delete some tables, and all, we'll see in this lecture. So SQL language, so it has been considered as a major one of the major reasons why this RDBMS was a huge success, because this SQL has become a standard language for this relational database, and most of the databases uses the same syntax and all for this SQL database manipulation. So that is why SQL is an important thing. So in this lecture, we'll see how to use this create command, alter command, drop command, then how to specify constraints. Then also we'll see how to specify key and referential integrity constraints that we have already seen in the previous lecture. And also there is we are going to exercises in this. So this is a database that we'll be using, and we'll be trying to create the database, or we'll be trying to create this DDL, data definition language commands, to create this database. So we have all these tables, or we call it as relations. When you come to SQL, again we have some practical or informal ways or informal definitions or informal terms in database. So instead of relation, it will be table here. Then instead of attribute, here we call it as attributes. So all the columns will be called attributes, and each tuple will be called as rows. Okay, so we can use it interchangeably. Now we'll see how to create this database. So in this lecture, we'll mainly see how to create this database, and if we want to alter a table, if we want to add something else, all those things will be dealt in this. Then how to specify this primary key, how to specify the super key, then other constraints which can be specified. All these things will be dealt in this lecture. So we'll be using this example to create this database employee. So first you will see how to create a table, how to alter table, and how to drop table. So I will use an interface to work with this. So this is an Oracle Academy interface. You can use any other online interface also. So I'll see how to write this. So we can type the SQL commands here, and all the results will be obtained here. When you press this run button, you can see the results here. Okay, so let me type the commands here. So it is not case sensitive. You can either type in small or capital letters, in whatever you want. It is not case sensitive. So I'm going to create table. So for that we have create and table. So we are going to create table, and first table is employee. So we can go back to this thing, and we can see that it can take this. So first we have to create employee, and these are the attributes. Okay, first name, middle initial, last name. So I'll create, and the name of the table should be given here. So the name of the table is employee. Then you can use brackets, or even without bracket you can write. So next thing, it is F name. So I will use small letters. For you can interchangeably use all these things. So for attributes, I will follow the syntax. So first attribute is F name. So first attribute is F name. So when you use in programming language, you have to fix the data type also. Similarly, in SQL also, you have to mention the data type of this attribute. So here we will see about the data types later. So for this example, I'll use capital letter for varchar. So it is a data type. Sorry, varchar of 15. So it means variable character of 15. So it is a data type that is used in SQL, varchar 15. Now I can specify a constraint, not null, because we cannot have a first name as null value. So this is actually a constraint. We will see about this constraint and all later. So I'm just simply creating this table. Okay. So anyway, you want, you can type. If you want to type in next line also, it is possible. So if you want to type in next line or same line, you can leave any number of spaces. It is not a problem. Like in Python and all, you can leave any space. Sorry, like in C, you can leave any blank spaces, white spaces and all. Then middle initial. So I will use variable name as middle initial. Since it is an initial, I will use another data type char, comma. Then next thing is last name. So last name, sorry, last name, I'll use this L name. Then we can use same varchar here. So we can use the same varchar of 15. So it means variable character of 15 length. We'll see that about this data type later. So I am using varchar 15, and that should also be null. I am specifying it as null. You can use capital or small, it's not a problem. I'm simply using it. So if you want, I will do one thing. I'll just write it in separate lines so that it will be easier to understand. So I am writing it like this. Then last name here. So first name, middle initial, last name, then comma. Next after that uh, we have this SSN, birth date, address, sex. Okay, so we can write SSN. So SSN, let it be small SSN, and let it be of type char itself. So I'll use char itself. Let me use char. And here I am going to specify the character size also. Here I have not specified, so only one character will be taken because it is initial. So it will be A or B like that. So I have not specified here, but here I have specifying char 9. And this cannot be null. You have already seen it is a primary key. So it can never be null. So I am specifying that constraint. After that we have birth date. So birth date is there, and birth date we have another data type in SQL. We call it as date. So birth date is actually a date. So there's a data type called birth date. Then after that we have address. So for address also we have to use variable character length. We will see why what is this varying character. Varchar of we will use 30. Then after that we have sex. It will be either M or F or whatever, T or something like that. So we will use char itself, only a single character is there. Then after that we have salary. So salary, so I'll use small letters. Salary, sorry. It's just to show distinguish between the keywords and other things. That's why I'm using capital and small letters. It is not necessary that you should follow these commands. You can type it in capital itself. All the things can be typed in capital, or all the things can be typed in capital letters, small letters. Any letters you can use. So salary. So I'll use another data type. So I'll use decimal, and within brackets I am mentioning it as 10 comma 2. 10 comma 2. Then we have another variable, that is super SSN. Next is super SSN. So super SSN, supervisor SSN. So I am using super underscore SSN. Okay, so let it be char, and SSN I have used 9 characters. So here also I will use 9 characters. So SSN it is 9 characters. Then we have department number. Department number. So it is department number. So I will use another data type. We call it as int. It is integer. So department number will be 1, 2, 3, 4 like that, some value. So I am using integer value. And it is not null. It should be not null because some department should be assigned to an employee. So it should not be have null values there. Then next, so if we take this, almost everything is filled now. So we have included all the attributes here. Now we have to specify which is the primary key. So we have not specified the primary key here. So in order to specify the primary key, what you have to use, what you have to do is you can use primary key. So primary key of SSN. Okay. So primary key of SSN will be included. Now I have included the primary key also. Okay. Now it is almost complete. So I have included the primary key also. So now it is almost complete, but I'll try to include the foreign keys also. So we have two foreign keys, that is super SSN and department number are foreign keys, and super SSN refers the employee table and department number refers the department table. So initially when I specify that thing, it will be an error. I will show why that error occurs. I am specifying it, it will be an error. Okay, definitely it will be an error. You cannot specify it now because the problem is we have not created the second department table. So it is trying to refer the second department table. So there will be an error. So in order to specify that, or else I will do one thing. I will simply I'll stop it here. I'll just simply specify, or I'll stop it without specifying the primary key also. So I will stop without specifying the primary key also. So I have simply specified the create table and I'll close this. Now if you want, you can put semicolon. It's not mandatory. In certain cases it will be mandatory put the semicolon like in C. So I have created this table with all these things. Now I'll run this thing. So this table has been created. So if you want to see the table, you can check it here. So that table will be formed. So all these things. So you can see that the name has been changed to capital letters. So I have typed it to show, to distinguish between all these key elements and all keywords and the user created words. So in the database, if you see, it is like this. And the data type that will be used is usually Oracle is not following this varchar standard. It will be following this varchar 2. It is same data type only. You will see what is the data type and all. So in this way we can create this table. So we can create this table. So all those things is defined here. And whenever we specify some null, so that null here it is no s. So first name cannot be null, middle initial can be null, like that it will be also specified in the constraint. So this is the thing we have specified. We can use this select. We will learn about the select command later. So this is how we have created a table. So in this way we can create a table. Okay. Now we have not specified the primary key and the super SSN. Okay, so before going into that, we have created this thing. So we have run this. Now what I will do is I will do something else. I will drop that table. So in order to remove a table, so there is another command. So if you see this, there is drop table. So we can, if you want to delete the table, so I'm going to delete the table since I have not created foreign key, primary key and all. I'll delete it. Okay, so I'll delete it, drop. Okay, let me before that I'll copy it. Okay, I'll drop the table. So in order to delete the table, in order to delete the whole table, I have to create, I have to tell drop. So drop command is to delete the table. So drop table. So you have to give the table name. Drop table employee. So when you do this and if you run this employee, so if spelling is wrong, employee. So drop table employee, and if you run this, you can see that that table has been dropped. And if you see that no tables will be there in this database. So that drop table is to delete the tables. Okay. Now I am going to create the whole database and then I will explain about data types and all. So I have created this thing not null. After that I am going to specify the primary key also. So in order to specify the primary key, so you have to use the term primary key and you have to mention in bracket which are the primary key attributes. So here only SSN is the primary key. Okay, so here SSN is the only primary key. So if you are using combination, then all the attributes should be specified. Here SSN is the only primary key. So with this you can run this. Now I will create this table. So there is some error. Just a minute. Oh, here D is there. That's why. Okay, create. So I have created this table. So the table has been created, and you can see the table in this database. If you see this employee table, you can see everything, and that here primary key is also being specified. Now we have specified SSN as the primary key also. Okay, so we have specified the primary key also. Now we cannot specify the primary foreign key now. So let it be like that now. So we have created this table. Now we will create the department table. So I have already written the command here. So I have the command. So I'm going to copy it here. Instead of typing, I'll be copying it here. So in the department we have, so in the department, sorry. So in the department we have this, I'll just copy it here. So we have to create department, and we have a department name here. So we have to specify department name, and we have given that data type as varchar, not null, then department number integer, not null, manager assistant character of not 9 and not null, manager start date as date, then primary key we have given as department number. Then we have specified another thing, unique. So department name. So if you see the data requirements, we know that both department number and department name can be used as uh, primary keys, because department number and D name are candidate keys. So primary key is department number. So unique of D name means D name is a secondary key, or it is a candidate key also. So in order to specify that, we can use the term unique, and inside that we have to specify which attribute is the candidate key. So this is primary key, and this is the alternate key that can be used. Then here we are specifying foreign key. So we are specifying the foreign key. If you see this thing, we have in this department key, we have a foreign key, that is manager assistant, which refers employee. So which refers employee. So since employee table has already been created, now we can refer this table. So that is why I am using foreign key, and foreign key is manager assistant, and we are using references. It references employee SSN value. So you can specify the foreign key like this. Okay. So in order to specify the foreign key, you have to mention foreign key. So in order to specify for primary key like this, and if there are candidate keys, if there are more than one key in that table. So if we take this table here, department number is the primary key. Department name is also unique. It can also be used as a primary key. So it is called the secondary key. So in order to specify that, we can use unique of D name. Then we are specifying a foreign key as manager SSN, and that manager SSN references. So this table, department table, references employee SSN. So this is the foreign key and refers the primary key of that relation. Okay. So we have run this and we have created this table. So that table will be created. You can see the table here. So both the tables will be created here. Department is there. If you check that department, all those things will be there. So department name, number, everything is there. Manager assistant, manager start date, everything is specified here. Okay. So this way we can create tables. Now I will create the rest of the tables later. Before creating that, we will learn something about data types and then return back to this table creation. Okay. So we'll learn about the different attribute data types. So what all data types can be used by the attributes. So first type is for numeric data type. So if we want to create numeric data types, we can have different data types, that is integer or int can be used. So you can either use simply int or you can use integer. So if you see this relation, we have used integer, int. Either you can use integer or both will result in the same thing. So you can either use integer or int, and then there are small int. Like in C, you have small int, long int, like that. We have small int also. Okay, small int can be used. So any of these things can be used to define numeric data types if it is integer data type. Then if you want to specify real numbers, you can either use float or real or double precision. So these are the keywords for those data types. You can either use float, real, or double precision. Okay. Then if you want to have formatted numbers can be declared by using decimal of I comma j, or decimal of dec of I comma j, or numeric of I comma j. So in the previous example, if you see this thing, I'll just take the other thing. We can see the history here. So I will use the previous example. So if you see this example, you can see that salary. So salary has been declared as decimal 10 comma 2. So decimal 10 comma 2. So the first 10 specifies. So first 10 is the precision. That is the total number of digits. So 10 specifies the total number of digits, and this 2 specifies the number of digits after the decimal point. So that is why 10 comma 2. So salary will be specified in this format 10. So total number of digits is 10, and after decimal point it is 2. So we can specify like this, decimal 10 comma 2. Okay. So we can use decimal I comma j, or you can use dec I comma j, or you can use numeric I comma j. All will give the same thing. So these are for the numeric data types. For integer, so real numbers, and for decimal in order to specify the formatted numbers. Okay. Then for character string data types, so in order to specify character data types or string data types, we can have fixed length character. So we have already seen fixed length character, char n or character n. So char of n or character n. So we have specified char of 9 here. So it means it is fixed. So the total number of spaces will be allotted will be 9. So you have to enter 9 digits. Otherwise there will be blank spaces in it. So if you are entering only 5, then the rest 4 spaces will also be shown. Okay. So that is fixed formatting. So char of 9 specifies that is fixed formatting. Okay. So here sex char means only one character will be assigned. Similarly, for middle initial char, only single character will be assigned. So here SS, super SS and char means 9 characters will be assigned. So even if you are storing only 3 characters, then the rest 6 character spaces will also be shown. So that is why it is called fixed character. Fixed character. Okay. So you can either use char, or you can use character of n. Okay. So you can use either char of n or character of n for fixed length. Then we have varying length. We usually use varchar of n, varchar of n or varchar 2 of n. We have already seen inside the database it is 2. So you can use varchar of n, varchar of n, or you can use char varying of n or character varying of n. Any of these things can be used. We usually use this varchar of n or varchar 2 of n. So it shows that it is variable character. So it shows that it is variable character. So here we have specified the first name as varchar of 15. So if the name is Arun, we use only 4 characters. The rest won't be used. So 11 characters can be saved. So that is why we use varchar. So it is varying character, varying character. So similarly for last name, if it is Thomas, we use only that much. Thomas means 5 spaces. The rest 10 spaces won't be used, and it won't be shown as blank spaces and all. So that is why it is varchar, varying character. So varying character, we can use any length. So it is varying character. So here also address varchar of 30. So 30 spaces can be allocated for that address. You can use any number of spaces. So that is the use of varchar. So varying character. Okay, you can use varchar or varchar 2. Then next type of data is bit string. So if you want to store bit string, in certain cases you may have to store bit strings in the database. Then you can use for fixed length is bit of n. So it is bit of n. So similar to char, you can simply replace with bit of n. Or for varying length, it is bit varying of n. Bit varying of n can be used. So n is so usually we'll be storing the bit representation like this. So b 101 10101 and within single quotes. This point 0.5 is not there. It accidentally came here. So actually it is b. We will start with the letter b. So it will be preceded with capital P, or it will be preceded with p, and within quotes we will write the string. So this is a string 10101. So within single quotes, you have to write the string. So this type of bit information, if you want to store, you can use this bit of n. You ignore this point and 5. Okay, this accidentally came in this slide. When I copied it from your textbook, it came here. Okay. Then another variable length bit string data type is there. We call it as a binary large object or blob. So it is available to specify columns that have large binary values. So if you want to store images and all, if you want to store images, it is a binary image. So if you want to store large images, you can use this blob data type. It is binary large object data type. So blob can be used. So blob of 30 G. So it specifies a maximum length of 30 gigabits of information. So like if you specify this data type like this, then it means you can store 30 gigabits of information, bit information inside. So this can also be used to store images and all block. Then we have Boolean data type. So in traditional Boolean data type, we have only two values, that is true or false. But in SQL, we have one more value, that is unknown value will be there. If we give some null values in the table. So sometimes in the table it will be null. Instead of those values, there will be null value also. So if it is null, then it will return unknown. So if you want to check whether something is there, so if you want to store true or false or unknown or null value, so there are three things that will be allowed. So it will return unknown also. Okay. So Boolean data type. Then another data type is date data type. So date data type has 10 positions, and the components are like this: year, month, and DD, and it is in the form. So that is why it has 10 positions. 10 positions, 4, then 2, and 4 to this 2. Then we have dash dash. So the total there are 10 positions. Year, so it will be in this format: year, month, 4 Y, then mm and DD. Then there is another data type for to specify the time. So time data type, it has 8 positions, and the format is like this: HHMM, HH colon MM colon SS. So hour, minute, and second. Then we have time with time zone. If you want to specify time with time zone, how much variation is there from that ordinary GMT time, Greenwich Mean Time and all, we can specify use time with time zone. Sometimes we use this kind of data type. We need not learn all these things. Just for your knowledge, I am saying this time with time zone data type includes an additional 6 points to this thing for specifying the displacement from the standard universal time zone. So we can use time with time zone. Then there is a timestamp also. Timestamp, it is another data type, includes a date and time fields plus a minimum of 6 positions for decimal fractions. So if you want to specify, if you want to find at what time a person has written an exam or submitted an answer sheet, so we have to get the exact time stamp. So for that we will specify the date and time field plus a minimum of 6 positions for decimal fractions of seconds, and an optional with time zone also. If we want to specify this time zone also, that is also can be used. So that qualifier, it is optional. So the timestamp will include this date, time plus 6 positions for decimal fractions for seconds. So it will be like this. Timestamp will be like this. So the date will be there. Then there is a space after that time, and after that, after point, how much second, 47.648, there will be 6 positions for this decimal second thing, so decimal fraction for this second. Okay, so in certain cases, when you want to find the exact time at which some information has been added, or we will use this timestamp database data type. Okay, so that's all about data type. Now we will continue creating the tables. Okay, so we have created this employee table and dependent table. Now I'll copy the rest of the things. Next table is department locations table. So department locations, you can take the thing, then you, so next is department location. So we have two attributes here. So I'll create department locations. So I'll create the department locations here. I'll use this thing. So create table department locations, and we have only two attributes: department number, it is not null, and department location. So we have to specify as not null because both the combination forms the primary key of this relation. Okay, so here combination forms, so department number and department location should be not null. So we have fixed it as integer value, then it is varchar of 15. Now we are specifying the primary key here. So primary key here is the combination of this, so we are specifying it in brackets, d number comma d location, and we are specifying the foreign key also. We have foreign key, so we have foreign key to this department, so we have a foreign key from d number to this department d number. Okay, so we have to specify that also. The foreign key is d number, references department d number. So you can run this C, and you can see that the table will be created here. So that table has been created here. You can see this table. So department, department locations, and employee table has been created. Okay. Now we will create the next thing. So next table is project table. Okay, project table. Let me see. It is up to here. Okay. So next thing, it is project table. We have P number, P name, P number, P location, and D number. Here the combination is the primary key. So combination is the primary key. So I will just copy this here. So create table, and we have P name. So we have P name with varchar 15, and it is not null. P number also integer with not null. P location is varchar 15. So we have not specified here as not null because P location may not be there. So sometimes it can have null values also. And here D num integer, and it is also not null. So D number is also there. It is integer, not null. Then here primary key is P number. Okay. So we have used only, okay, P number is the primary key here. This combination is not taken. Okay, P location can have null values. That is why we are not taking that thing. Maybe some mistake in this diagram. So here P number is the primary key of this relation. Then we have an alternate key also. So that is P name. It is also unique. P name is also unique. So it is another candidate key. That is why we used unique P name. Then we are specifying foreign key. So we have a foreign key D num, which refers the department table. So D num, which references department D number. So this way we can create, you can run this table, and you can see that table has been created. Okay. Now we will create the next table. Next table is works on table. Okay, works on table. We will copy this thing. So we will see this works on. We have ESSN, P number, and hours. And this combination, ESSN comma P number, that combination forms the primary key of this relation. And we have two foreign keys here. P number, which refers this employee table, and ESSN, which refers this employee table. Okay, I'll copy it here. So create table works on. We have ESSN, which is character of 9, then P number, which is integer value, then hours. So ours, it is, I am using decimal 3.1, total 3 decimal places, and after decimal point it is 1. Then here primary key, it is a combination of ESSN comma P number, and here foreign key we have ESSN, which refers the employee SSN. Similarly, P number, which references the project number. Oh, so okay, here it is P number. Okay, we are using, we have not specified this D number, so that can also, so this diagram we have some mistake. We can, if you want, you can specify this D number which refers this table also. Here I am using P number. So oh, sorry, this one. Okay, this is right. Okay, P number which refers this P number, and ESSN which refers this employee table. So that is what we have specified. We have ESSN which refers employee, then foreign key P number which references project number. We can run this, and that table will be created. So we have created that table also. Now next is we have to create dependent table. So dependent, the primary key is a combination of these two, and ESSN, there is a foreign key which refers this employee table. So we can take this thing. I have already written this thing. So I'll copy it here. So I have copied it here. Now create table dependent ESSN. It is not null. Then department number, it is also null. Then sex, it is character. Then birth date, we have given the data type as date. Relationship, it is also variable character. Here primary key is a combination of ESSN and department name. And foreign key, it is ESSN, which refers the references employee table. Okay. Now you can simply run this thing. So when you run this, the table will also be created. So there is some, it is taking time to create this thing. Okay, table has been created. Now you can see the table. So it is department, dependent, then department locations, employee, project, and work zone is there. So we have created all the tables. Okay, so we have created all the tables. Now there is a problem here. Even though we have created all the tables, one thing we have not specified it, because if you take this thing, we have not specified the foreign key of this super SSN and D number, because super SSN refers this employee and D number refers this department. So when we created this employee table, this department was not there. So we had not specified this as foreign key. Similarly, the foreign key of this table is also not specified. So in order to do that, so we have another thing that can be used to specify this thing, that is alter table is there. So if you want to change the definition, of this thing, you can use it. Alter table is there, so we have to use alter command. So I think I have the command here. So I will use the alter table. Now I am altering the employee table. So I am going to alter the table because I have not included two foreign keys there. So I am going to alter table. So alter command can be used. So alter table, then the table name. Now add. So what should be added? So add foreign key super SSN, which references employee SSN itself. Okay. I think I didn't specify the primary key also. I forgot whether I think I specified. Okay. So if I have not specified, you can add primary key also. If you want to change the primary key also, it is possible. So it is alter. If you want to change the schema of a table, you can use this alter table, employee, then add foreign key super SSN, which references the same relation. So in this super SSN refers the SSN of employee itself, recursive relationship. We have already seen that thing. So it references employees SSN itself. Then we have foreign key D number, which references department D number. So we are altering it. So this is alter. So if we run this, alter table will be done. So there is some, the network is slow, might be. Okay, it will run, no problem. Okay, so with that you can use alter table. Using this alter table notation, it is possible to alter the schema. There is some error. Let me check it. So you can use this alter table like this. Alter table employee. Then you can add a foreign key. Super SSN references employee SSN. So then it will become this one. So I have already run this, so you cannot run it again. So it is already existing in it. So this is a command for that. So alter table employee add foreign key super SSN. So it is alter table. You can add. Similarly, if you want to add the department also, that is also possible. So alter table employee add foreign key department number references department of D number. So this will add the two foreign keys which we were not add, which we didn't add when we created the table. Then if you want to add columns also, it is also possible. Alter table employee add a new column named job where care of time. So that is the use of this this alter table. So you can add this thing, and if you want, you can drop something also. So in this way you can do all these things. Now if I want to describe a table, so if you want to describe a table, it is possible. DSC, you have to simply write employee. Okay, and if you run this, you can describe that table. There's some it is going on, so you can describe, so it will show the description of the table. Okay, there is some problem with that. We will come back to that thing later. Okay, so we have seen this alter, drop, all these commands, or we have seen the different attribute types. Next, how to create domains. So if you want to create domain also, it is possible. So that is, if we have many SSN, like we are using SSN for employee, then manager SSN is there. So if we want to specify that all these SSN are from the same domain, you can create using this create command. Create domain SSN, you are giving a name SSN underscore type as char9. So everywhere you have used the char9 for SSN, manager SSN, ESSN, for everywhere we have used the same thing. So in order to specify that, SSN underscore type can be. So we create this domain, and after that when you declare, you can simply use SSN underscore type instead of char of 9. So everywhere it will be that type, char of 9 will be there. So instead of using char of 9 data type for when we create that SSN, you can use SSN underscore type. So that is domains in SQL. Then to specify this constraints, create table, we use this not null, and you can specify constraint like this, not null and default value. If you want to give some default value, you can specify default value as 1. Let me see whether it has been running. Okay. It is coming. Let me check it out. So describe, let me see whether it will work. Otherwise we'll go back. Anyway, to describe this table, you have this command dsc employee, or you can use describe employee. So all the structure of the database will be stored here. You either use dsc employee, any table can be described using this command. Okay, let it be there. So you can use this create table. So in order to specify this default value, you can specify like this default one. So if no value is being entered by the user when we insert some data element, it will take the default one value. Then you can specify constraints like this: d number int not null, check whether d number is between 0 and 21. So you can so when we create this table, you can specify when you create this d number int and it is not null, and also to check. So this is a constraint, check whether that d number value entered is between 0 and 21. So then only it will be accepted, otherwise it will show an error. Okay. Then if I want to create a domain for some other integer dnum, so we can create a new, it is like creating a new data type. So wherever you want to use integer, you can replace it by using d underscore num. Then you can use the same dnum for to check like this. So check d underscore num is greater than 0 and d number is less than 0. So this is similar to checking the department number. So these are things to, so this check is actually to specify the constraints. If we want to include some constraints, we can include such kind of other constraints. We have already seen different constraints, key constraints, integrity constraints, and referential integrity constraints. Then after that, we have seen other types of constraints. So these are specific to the particular column. So if we want to specify such constraints, it's possible using this check thing. Okay, check constraint. Then how to specify key and referential constraint, integrity constraint? We can specify either by using the previous definition, like primary key. Inside primary key, you can give in brackets. Let me check it out. Okay, so we have described this table. So this is a description table that we have already seen. So we can get the description of the table, employee, which are the columns, and what are nullable things, everything will be displayed. So DSC can be used, or describe can also be used. And we'll take this history. I'll take this history. I'll use some create table. Let me take this thing. So if you see this thing, we have specified the primary key like this, primary key of SSN. So rather than specifying like this, here itself, if you want, you can specify in after SSN, you can specify it as primary key. So that is what we have seen here. So D number int primary key, we will specify during that definition itself. So if there are candidate keys, we will specify like this, dnum varchar of unique, instead of specifying unique of dname like that. So we can specify like this also. Okay, this is another way to represent the primary key and unique or candidate keys. Then foreign key, when you specify this foreign key, we can specify this referential triggered action. So we have already seen foreign key in the previous lectures when we studied this integrity constraints. So when we specify why we specify this foreign key is we are referring some other table. So what happens is actually we'll take this thing. So we have different tables, department, dependent, department location, like that. We have different tables. Now we have there is a referential relationship between employee to dependent. And if we try to delete this employee table, so what happens to that referential integrity? Or there is some relation between this dependent and department and project. So if we delete some project, so that referential integrity constraint should not be violated. Or when we insert something, that referential integrity should not be violated. We have already seen if we delete something, referential integrity constraint should not be violated. So in order to prevent that violations, what we do is when we will specify this referential triggered action. So if something happens, if some insertion, some deletion or something happens, what should be done for that referential integrity? So we can either specify as set null, cascade, set default, like that. So if something is deleted, we may set null or cascade that operation so that it is affecting the other tables also, or we'll set some default value to be entered. Okay, we'll see example, then you'll understand. So option must be qualified with other on delete or on update. So if we perform a delete operation or delete on update operation on that table, so these things, this should be triggered. So I'll show an example, then you'll understand. So for example, in this employee table, so this is a constraint. We'll leave all these things here. Now we have a foreign key here. Foreign key we have specified super SSN references employee SSN. And if something happens, if some deletion operation happens to this super SSN value, if that employee is deleted, so what it has to done? So on delete, we have to set that super SSN value to null. So that is what we are specifying here. On delete, set to null. Or if an update occurs in this table, we have to cascade it. Cascade means we have to update in all the reference relations. Similarly here, foreign key department references department number. So if some deletion occurs and if there is some violation of constraint, foreign key, that referential integrity constraint, if it is occurring on delete, we will set some default value. So we have given default value as 1. So if that is deleted, then department value will be default given as default value. Or if some update operation happens, then that cascade operation should be done. Cascade means it has to be affected in all the tables. If you are changing some department number value, then that department value should be updated in both these tables. Okay, if we are changing department number 1, now we have a department number 5 for research. So we are changing the department number 5 to department number 6. Then it should be changed in the employee table also. Okay, so we have to change that thing in all the tables. So for that only we use this cascade thing. Okay. So on delete we can use anything. On delete you can use set to null or set to default. On update we can set to null or set to update, or cascade thing can be done. This is another example for in the department table. So here we have this foreign key manager SSN which references SSN. On delete we are setting it to default, and on update it is cascade. And this is department locations tables. On delete it is cascade, on update also it is cascade. We are asking to cascade, so it should be those operations should be triggered in all the relations. So this is known as referential triggered actions. So those kinds of triggered actions will also be specified in order to prevent that referential integrity violations while inserting, deleting, or if something happens to the table. Then we can specify constraints on tuples using this check relation. So for particular rows, if we want to specify this constraint, we can use this check department create date is less than. So if somebody enters the manager start date, it should be greater than this department creation date, because a manager can be employed in the department only after that department has been created. So such type of constraints can be included for a particular row if I want to specify for a particular tuple. So it is also possible. Okay, so that is referential integrity constraints. Then then I will show something other than this. I will show how to delete a table. So if you want to delete a table, so for that what you have to use is drop. So you have to use drop employee. So drop employee, when you run this, it should be deleted, but this won't be get deleted. There will be an error here, because we cannot delete this employee because it has some reference relation. Some other tables are referring this table. So we cannot delete this, but we can delete dependent table. So we can simply delete this dependent table. There won't be any problem while we delete this. Sorry, drop table. So that name should be there. Sorry, drop table dependent. Drop table dependent. So drop table dependent, if you run this thing, that table will be dropped. Now if you check the tables, that table won't be there. So using that table, so that dependent table has been deleted. So you can use this drop dependent table. Now if you try to delete this thing, employee table, it won't be possible. So you won't be able to delete this employee table. It will give some error because it is referenced. So this is referenced by some other foreign key. Some other table is referencing this table. So there are some unique or primary keys in table. So it cannot be deleted. So in order to delete such kind of things, what we have to do is we have to use cascade. Delete drop table cascade constraints. So all those constraints, without violating, we can delete this. So now the table is dropped. Similarly, you can delete any table if you want to drop department. So that is also possible. So if you try to drop it, you can drop table department, cascade the constraints. Then you can delete that thing also. So that table, drop table, so okay. Let me check drop table cascade. Let me check whether there are any constraints. You can drop it. there is some thing. So you can use the same constraint. So you can use, you have to use cascade all those constraints. Simply specify cascade constraints. You can drop that table. So that is all about this dropping this table. So similarly, you can drop any table. So the delete the table, it is drop. So we have seen alter, create and drop, create, alter and drop. So I have to create, I have to alter, and you have to drop this. So all these comes under data definition language, DDL commands. So all these will come under DDL commands. So check all these to specify the constraints. Now I'll show an example. So you have to do this as exercise. We have the airline reservation system, the same thing we have used. So this is the ER diagram for that: airport, flight, then flight leg, and lake instance. So these are the different attributes in it. So you have to create these tables. Okay, you have to create these tables, then you have to specify the foreign key. All these constraints should be specified, and this is a second set of tables in it: fare, then airplane type, then can land, airplane, and seat reservation. So these are the different tables in it. So you have to create all these tables with all these attributes, and you have to find the foreign key of these, and you have to use the primary key, foreign key. You have to give some appropriate data types, everything. So this is the exercise. So you have to consider the airline database shown. What are the reference integrity constraints? Then write appropriate SQL DDL commands to define the database. So you can try this exercise. If you want, you can have some online SQL online SQL compilers will be there. You can write the commands and check it there, or you simply write this program. So this is also important because for GATE or for university exam, you need to write this SQL commands. You will be given some ER representation, ER diagrams, and you will be asked to create this table by specifying this primary key, foreign key, and all. And this is another example. This is the book database. So this is also available in a textbook in your example. In the exercise, it is there. So this is the book table with different tables: book authors, publisher, book copies, book launch, library branch, and borrower. And these are the different attributes. All the foreign keys are, everything is mapped in this table. Now we have to create this DDL commands. So consider the library relation, choose the appropriate action. Like you have to use this reject, cascade, set to null, set to default, whatever for reference integrity constraint, both for the deletion of a reference tuple and for update of primary key attribute, etc. So you can justify your choices also. So try doing these two things. Okay. So what you have to do is you have to create the DLDL. All this, whatever you have learned, you have to apply these two tables, and you can submit it in the classroom. Then write appropriate SQL DDL commands for declaring the library relational database, specify the keys and referential triggered actions also for this library database. Okay, so this is a reference. Thank you.